Hello, hi everybody, this is Isha Elson here. We are very sorry for the delay, we are facing a few technical difficulties. So I hope you guys can understand. If you can hear me or if you can just see my screen which we are projecting right now, please type in the chat box and tell us. Perfect, perfect. Thank you so much for letting us know. Okay, and I just want to tell you what we'll be covering today. So today we have our CTO and our CEO who will be talking about various basics of Wi-Fi and networking. Okay, so our CTO will be talking about RF technology, the evolution of Wi-Fi, frequency, interference, MIMO, then speed versus range, crowding, coverage holes, radiation blindness, and path heterogeneity. While our CEO would be talking about managed versus unmanaged, the challenges you have while installing a Wi-Fi setup, installations while installing a setup, then Wi-Fi practices, public Wi-Fi regulations that you have from the government, etc., and the value proposition that our products bring in. Then let us proceed. Okay, so I just want to give you a little brief about who we are and what we do. So I don't know whether everybody is aware, but we are a 12-year-old company and we have offices in 3 countries and presence in 45 plus countries. We are the top 3 in the hotspot companies in the world, and we have resellers in 20 countries. We have a very, very good, strong support system wherein, we get inquiries 24/7 from our clients, and that has been handled professionally. And we were the brand of the year in 2016, which was given to us by Silicon India. And we are just a one-stop requirement for every need that you might have when wireless technology is concerned. We are a one-stop shop, which means that we provide APs, switches, we provide controllers, both cloud and physically placed controllers. Okay. So, and we have a lot of client base as well. So these are some of our international marquee clients. Like you have Whole Foods, Turnkey, Signet, Hamburg Airport, Intercontinental Hotels, Holiday Inn, some very big names in the foray. Okay, then this is a list of our marquee domestic clients, wherein you have DMRC, which is one of the biggest projects we are doing in India. It's a huge project. Then we have KPIT, we have Microsoft and Volvo as our clients. We have various hospitality and other industries also, which obviously cannot be covered in just 2 slides. But yes, these are some of the good names that we would want to showcase to you. Now I would like to introduce my CTO, Mr. Sohail Ahmed, to take forward the presentation. I hope you guys enjoy yourselves.
Good afternoon, everyone. Thank you very much for joining us today. In this webinar session, I will be covering some of the topics which are very relevant for building a truly robust and reliable Wi-Fi network, and these are mainly related to RF or wireless technology. In case you have any questions, please keep typing it in our chat box. I'll take them by the end of this session. So let me start. I'll be talking mostly about those important issues that we have learned over years people are facing in the field, especially those who are responsible for designing or implementing a Wi-Fi network. And these issues are mostly related to interference, crowding problem, coverage, radiation, and let me start first with giving you the basics of Wi-Fi, how it started and where we are right now. The first standard was finalized in year 1999, and that time this standard was able to offer about 11 Mbps of link speed. And by 2003, the standard evolved to a next level where the new standard was introduced, 11G, and it was able to achieve about 54 Mbps speed in that standard. And then about in 5 to 6 years, a new standard was released in 2009, and the technology was able to offer about 300 Mbps. And the most recent one is 11EC standard, which was actually started or introduced in 2012. And with this standard, the standard body could actually cross beyond the gigabit speed limit. So if you look at the evolution, you will find that almost every 4 to 5 years there is a new standard coming in the foray. And the most recent one is 11EC standard. The researchers are still working on a new other standards which has not been, productized or available in the market, but I just wanted to name them. There is another standard called AD.11 AD and AX standard that offers even much higher speed. With this background, let me talk to you about the kind of frequency bands which are being used by Wi-Fi technology. Wi-Fi uses two different frequency bands. One is 2.4 gigahertz, and then the other one is 5 gigahertz frequency. In 2.4 gigahertz, there are about 11 channels. We say there are 11 channels, but technically there are only 3 non-overlapping channels, and I'll explain you what does that mean. In 5 gigahertz, the spectrum width is really big, and there are almost about 25 channels available in 5 gigahertz band. As you can see, these channels are numbered. In 2.4 gigahertz, it is numbered starting from 1 to up to 11. Channel number 14 is special, which is allowed in Japan. In 5 gigahertz band, the channel number is starting from channel number 36, 40, 44, and so on. And the last, the entire spectrum is divided into 3 parts, 3 bands, which is called UNI, upper band, middle band, and lower band. In this particular frequency, there are only 5 channels in lower band and 4 channels in upper band, which are technically usable because the other channels like channel number 52, 56, 60, and so on, they are DSS channels, which means it can be used for operating radar, and there is a special compliance needed in order for Wi-Fi to operate on these channels. So now I will be talking about the interference problem. The interference problem, there are 3 categories of these interference problem. One is called co-channel interference. The co-channel interference happens when you have more than one access point operating on one channel. It could be 2.4 gigahertz channel, or it could be 5 gigahertz channel. But all APs are operating on same channel, which means they are sharing the total bandwidth or total capacity available on that channel, which means the users connected to one access point is not going to utilize the entire bandwidth. They will be sharing it with other access points and other users. So this is an example of co-channel. The cross-channel interference happens when you have 2 access points operating on 2 different channels, but they are very close to each other. So the transmission from one channel goes on the another channel, and it starts interfering the transmission or reception of other access points. So overall, these interferences bring down the total throughput of the network really down. The third category of interference is non-Wi-Fi based interference. As we know, Wi-Fi band is completely license free, so many other devices operate in this frequency band. For example, You can have a microwave, cameras, Bluetooth operating also on the same band, and they interfere with your Wi-Fi network, and which causes performance degradation over time. So let's talk about 2.4 gigahertz frequency band and how the interference affects in this particular band. In 2.4 gigahertz band, there are all the channels are actually isolated by 5 megahertz only, which means 2.4 gigahertz requires megahertz size, and they are separated only by 5 megahertz. So if you put one access point on channel number 1 and another access point on channel number 2, they will start interfering with each other because the total separation between these two channels are only 5 megahertz. What happens when you further push one access point on another channel, say one is on channel 1 and another is on channel number 3? Still the total separation between these two access points is 10 megahertz, while one channel requires entire 20 megahertz. So still there is some overlap, and whenever they transmit, they interfere with each other. So this is still not better. So what happens technically when you put another access point on channel number 6? The total separation between these two channels become 25 megahertz, which is more than what is required for one access point to operate on one channel. So this is really good. And the same happens when you put one access point on channel number 6 and another access point on channel number 11. The total separation is really more than needed. That's why we say in 2.4 gigahertz you have only 3 non-overlapping channels. Although we have 11 channels to operate, but technically there are only 3 non-overlapping channels. So what happens in 5 gigahertz band? Do they really interfere? No. Over the period, designers actually learned about it, found that the interference can really create a big problem. So they designed channels in 5 gigahertz band in such a way that they are actually separated by 20 megahertz. So your channel 36 and then your next channel is 40. So there is actually 20 megahertz separation. So you can configure your access point on any of your 5 gigahertz channel, and they will not interfere. So there is no question of non-overlapping interference due to overlapping channel in 5 gigahertz band. But what happened over a period, new standard was introduced. We saw a few minutes ago. In 5 gigahertz, we have a 40 megahertz channel as well as 80 megahertz channel. So this non-overlapping interference was due to only 20 megahertz channel. But when you configure your access point for 40 megahertz channel or say 80 megahertz channel, that time you have to be really very careful whether you are interfering with other channels or not. The other groundbreaking technology that was introduced was MIMO. It stands for multiple input and multiple output. The technology was first practically available with the standard 802.11, and it made the total link speed from 54 Mbps to go to up to 300 Mbps and theoretically up to 600 Mbps. So what happens? How did we achieve this much increase in the speed? The main reason behind that was in MIMO technology, transmitter can transmit more than one signal streams simultaneously, and receiver can actually decode all the streams coming to it. Before MIMO technology, transmission coming from multiple directions, or you can say multipath, was not seen as a good thing. The receiver was not capable of decoding that signal. But with MIMO technology and advancement in the electronics and DSP, it was possible to separate multiple streams coming on the receiver. And that helps us to transmit more data bits or more information by transmitting multiple streams in one go. So this is about MIMO technology, and both 11N standard and AC standard is using it. With MIMO comes the confusion, which is better, 2x2 MIMO, 3x3 MIMO, 4x4 MIMO, and you might have heard about vendors claiming that their access point is, 3x3 or 4x4. But what is important is to understand in what kind of environment we are going to use this kind of devices. Obviously, the more the better, but you need to understand what different equipments you'll be using. For example, in a public hotspot, you can imagine that most of the users will be smartphone users. And these smartphone devices are, even today, they are only using 1x1, which means they cannot really leverage the capability of Wi-Fi access point if the access point is 4x4 or 3x3, or for that matter, say 2x2. So one can think of, implementing infrastructure which can at least stay for relevant for next 5 years. And in that case, we can safely say that, okay, we can choose a 2x2 access point for a public Wi-Fi hotspots, because most of the users are still carrying 1x1. So they will most likely next 5 years they will go to 2x2, which is still a challenge because these are battery powered devices, and when you go from 1x1 MIMO to 2x2, you need more energy or more battery backup. Even most laptops these days are just 2x2. They are not even 3x3 or 4x4. So in assembly, one can think of implementing a 2x2 MIMO. A dual radio access point, and one can choose 11 AC access point which can do up to 1200 Mbps. In enterprise environment as well as assembly, since people are using their laptops or PCs for connecting, it's better to design the network so that it can stay relevant and handle a really dense user in deployment. So 2x2 or more MIMO is really good for that kind of setup. The other confusion, or you can say myth that still exists in Wi-Fi world is related to speed versus range. They are really related, and you can't really achieve both. Either you can achieve speed or you can achieve range. You can't really have a very long range and a very, very high speed. That is technically not possible. So what happens is when we talk about range, most of the vendors advertise the range of the lowest link speed, which is around 6 Mbps. At a single speed, 6 Mbps, you can really reach to the farthest point, but not for 300 Mbps. So if you are able to achieve, let's say, a range of 100 feet at 6 Mbps, most likely you will be able to achieve about 30 to 40 feet of range when your devices are operating at 300 Mbps. So it is very important in terms of designing the network and in terms of setting the expectation from the Wi-Fi network. The other challenge that we face while designing the network is related to crowding. A lot of access points which are not capable of handling the load or doing a dynamic load balancing. This kind of problem can be seen. What happens is in a dense deployment, one access point gets most of the load. You can say around 20-25 users are connected to one access point, and the same another access point which is just few feet away does not get more than 3, 4, 5 users. So if the access point is really managed access points and it is really designed well, then they can dynamically load balance the number of users. And what happens is when the users are load balanced, your total network throughput goes up and the user experience really go high. The other problem is observed in a Wi-Fi network is related to coverage holes. There is no sophisticated tool available, and as we know that this entire Wi-Fi technology is an invisible technology. It is not possible for us to visualize it, and that requires a use of sophisticated tool or automated system which can actually provide a visibility into network when we deploy Wi-Fi access points. So if we are not using Wi-Fi survey tool or coverage tool, then there are some areas where we do not really get a very good signal, and the users face problem. So there are software available that can be used, or a manual site survey can also be used to find out the coverage holes. Another problem which exists in Wi-Fi world is related to radiation blindness. What happens is these days most of the access points, especially the enterprise grade access points, are highly optimized for the type of deployment they will be used in and the kind of mounting that is supported. For example, if you take a ceiling mount access point, the ceiling mount access point is highly optimized to provide a very good coverage in the horizontal plane. But what happens when you take the same access point and mount it on the wall? Your radiation pattern completely changes. Instead of increasing the coverage in the horizontal plane, most of the coverage is going in the vertical plane, and you may see users facing connectivity problem or coverage problem. So it is very important to understand while deploying the access point for what type of radiation pattern is supported in that access point, and then deploying that access point accordingly. Then the last challenge that I would like to cover here is related to path heterogeneity problem. What happens especially in the outdoor deployment environment? The people expectation is that I should get Wi-Fi coverage up to, let's say, 200 feet or 300 feet. They think that, okay, when my phone can see a Wi-Fi network available, then why can't I connect to that? What is important to understand here is that the access point is programmed to transmit at a really very high power. It can do up to 30 dBm transmission, while our mobile devices are not capable of transmitting at that high power. Especially the main reason is they have to save the battery life. So they can transmit at max 20 dBm, while access point can transmit at 30 dBm. So mobile phones are able to listen to what access point is broadcasting, but when mobile phone sends some packet to the access point, it does not really reach to access point. And this problem typically creates a path heterogeneity problem, where the mobile phone is not able to establish proper connection, and people really conclude that there is some issue with the access point. So to basically summarize this point, the range of these days, the range is not really limited by the access point, but it is actually defined by the type of devices that will be used with the access point. So you can see when you are using a laptop has much more better antenna and better transmit power, so you can get really very good range with laptops. You will get a lesser range when you are using a tablet, and really low range when you are using a smartphone. So the main deciding factors for the range is the distance between the access point and the smartphone, the speed at which they are transmitting, the total noise on the channel, and line of sight. These are the 4 parameters that define the kind of user experience that a user will get. With this background, I would like to wind up my session. I'll hand it over to Mr. Rishi Ghare, who will talk to you about Wi-Fi network related challenges. Thanks.
Good afternoon, everyone. First of all, thank you for joining this webinar. We hope to continue having this webinar series every month to educate our customers, our partners, our good wishers about Wi-Fi and how Wi-Fi can be made better, more reliable, faster, and how we as a company can also help many of you build a robust Wi-Fi network. For those who want to ask questions, please type them in the chat window. After my talk, we will actually open the floor for questions and answers, and we will kind of try to answer your questions as much as possible. So with that in mind, let's go forward. The topic I'm going to cover primarily is robust Wi-Fi. Already Sohail has highlighted a lot of technical details. I'm sure some of them you would be already knowing, some of them you would have learned today. And there's a lot of technical details that happens behind the scenes when you deploy Wi-Fi networks. And it is important for you when you deploy these Wi-Fi networks to understand some of these nitty-gritty details and the limitations as well as the advantages of using Wi-Fi. When we talk about robust Wi-Fi, what does it mean? Is the first basic question, because many people ask us this question: oh, we want our Wi-Fi to be super reliable, it needs to be super fast, it needs to do this, it needs to be just flawless. But they fail to understand, one, are some of the challenges in Wi-Fi as well as what it means by a robust Wi-Fi design. So one thing, it needs to be a simple design. It needs to have a good coverage. You also need to have a good channel utilization. So you need to design the network in such a way that you optimize your channel utilization. Then any Wi-Fi network, if it is not managed or monitored, it really can't be made robust or reliable. So you need to have monitoring tools and monitoring processes in place in order to enable your make your Wi-Fi robust. Then you need to have some external protection, and so your Wi-Fi needs to have enough protection. Maybe it is a firewall, or these are tools which are going to detect intrusions and so on. And although Wi-Fi can offer you 300 or 1.2 Gbps connections, if your backend connection, your leased line or your fiber connection is not enough, you are never going to achieve a good throughput. So you need to, robust Wi-Fi means also a good throughput. And lastly, it needs to have a maximum user handling capacity. With that in mind, I've created a table which says what are the differences between a managed and an unmanaged Wi-Fi. Now, what is unmanaged Wi-Fi according to us? Unmanaged Wi-Fi is essentially a network that many hotels or many enterprises just set up a Wi-Fi router. They buy a D-Link or a Linksys router from the market, and they configure the SSID and they configure a password, and they set up a Wi-Fi. And when we go to them, they say, oh, we have a Wi-Fi in our hotel or in our premises. But that's not what we call as managed Wi-Fi. That's pretty much unmanaged. You don't know what is going on. You don't know the performance of the network. You don't know anything about that. It's completely transparent to you. So a managed network will give you better throughput, whereas an unmanaged network, you have no clue how much throughput you are getting and what kind of speeds people are getting. A managed network is going to give you more visibility into the network. Unmanaged, absolutely no visibility. You don't have anything it's just running. That's all you can see. In a managed network, you talk about proactive failure mitigation. So what I mean by that is you come to know that there is a problem that is going to happen, or there is more proactiveness in solving the customer issues. Whereas unmanaged is more or less reactive. Reactive means when the customer starts complaining, that's when you start taking actions. So it is about not monitoring the access points. If the access point goes down, someone cut the cable, that's when you'll come to know. Whereas in managed, you get more proactive action. As I said, it is monitored, that is unmonitored. A managed network can have better RF design because you know what channels you are running on, what interference you are causing, so there is less interference. Whereas unmanaged will have a more unpredictable RF. It will be a very unpredictable RF design or RF interference will be there. Obviously, managed, we believe, should result into less customer complaints, whereas you get more customer dissatisfaction for unmanaged. And manage, you can shape bandwidth, you can control bandwidth, whereas a unmanaged network is basically a bandwidth hogging network. So what are some of the Wi-Fi challenges? Well, many of you do Wi-Fi installations, you use Wi-Fi, you do installations. So there are some, let's understand first of all, what are some of the basic challenges that are there. So first and foremost, all of us know that Wi-Fi operates in an unlicensed spectrum. So because it's unlicensed spectrum, you don't control which other devices and which other networks are operating near your vicinity. So you need to, when you're designing any Wi-Fi network, you need to know that first and foremost that you're working in an unlicensed spectrum, and you're going to have even after installing the network, you are going to have continued challenges keeping the network robust. Because after a while, another access point might be coming up there, which is in the same, going to be in the same frequencies and going to cause interference for you. Wi-Fi generally tend to have more interference than other networks. When you talk about other networks like the 4G network or any other networks where we are talking about licensed spectrum, Wi-Fi no doubt is going to have more interference. So I mentioned to you about channel width. So you have limited channels or limited channel width to operate on. Also limited coverage area, as in Wi-Fi by design itself or by regulation. The regulatory bodies have made sure that people can't broadcast a Wi-Fi signal more than 1 watt from any access point. So if you buy any access point anywhere in the world, you will not be able to broadcast more than 1 watt of signal through that access point. So that means you always will going to have a limited coverage area. Then we also believe there are a lot of misconceptions about Wi-Fi, as in people think Wi-Fi is magic and everything is going to happen and everything is going to work on Wi-Fi, but that's not true. Everyone, especially people who do install Wi-Fi or manage Wi-Fi, they need to understand these misconceptions and also manage customer expectations. I think Sohail had highlighted some of those misconceptions in his earlier talk. And other important thing is Wi-Fi is very unregulated. So there is no, although there is a Wi-Fi alliance is there and there are a few other bodies, but largely speaking, growth of Wi-Fi is unregulated, as in there is no body, worldwide body or even a national body which actually regulates Wi-Fi and ensures that let's say everyone is going to have similar SSIDs or going to have similar kind of antennas and so on. There's no such regulation. Pretty much you are free to do anything you want in this technology. And again, one more thing is too much expectations. I mean, people think they can achieve a lot of things on Wi-Fi. They want to stream high definition videos and they want to do lot more things. But they fail to understand that the technology itself has limitations and they need to have much better designs to manage those expectations. Noise and signal degradation is another factor, and rogue SSIDs are some of the other challenges. So these are some of the challenges, and it's important as an operator or an installer of Wi-Fi to know these challenges and ensure that you try to reduce those challenges as much as you can. Now I'll come to installation issues. While the technology itself has some challenges, there are also a lot of installation issues that we foresee or we see that our partners do when they install Wi-Fi. One of the foremost is the bad RF design. So there are a lot of overlapping channels. There is no sufficient thought given to how the RF design needs to be there. Everyone thinks that they can broadcast as much power as take the access points to the maximum power and broadcast as much as possible and as far away as possible. So, or try to reduce access points by increasing the power from the access point. That's another common notion people have about when they design Wi-Fi. Often we get customers who say that, oh, I have a big hotel. We just want to install 2 access points and that's enough. Again, these are some, there is no way you can achieve this kind of, or build a reliable Wi-Fi if you have these kind of expectations from your customers. So bad RF design, improper channel assignment, The antenna selection is also an equally important topic, as in you need to understand where you need to have a omnidirectional antenna, where you need to have a sector antenna, where a directional antenna, what are the purposes of each of those antennas, and how those radiation patterns affect the reception of Wi-Fi by the end devices, as in, or how the signal propagates when you install that antenna. Generally speaking, people again, they just take its omni antenna and think that it's going to solve all the problems. But that's not true. There are different types of antennas, and each of them has a certain characteristics, and it's important for you to understand which antenna to select for what kind of application. The network design or network structure that you have in place is also equally important. One classic example is people don't pay good attention to crimping, laying out cables, the power that you provide is not properly planned, and so on. Too much power, that is something I already highlighted, that when you install Wi-Fi, just broadcasting every access points at the maximum power, it doesn't make sense. And it's just going to create a very bad Wi-Fi installation and bad user experience. So you need to have a right power given to every access point, and that's precisely the reason why almost all the good Wi-Fi companies have a option for you to regulate the power. You can control how much power each access point is radiating from to the end user. Crimping, mounting of access points is also equally important, or we see these as people, they don't do these things properly, and then they get bad Wi-Fi installs. Device selections. So this is again an example of not knowing about how the networking works and what are the limitations of every device. So a classic example is people buy an expensive Wi-Fi access point. It has a gigabit Ethernet port, and it has all good things. It is AC power, it is 3x3, 4x4, and so on. But when they connect it to a switch, they might connect it to a 10x100 switch, and when they start actually running the network, if you are having a 10x100 switch connected to a gigabit access point, it's really not going to help you, because you are never going to achieve speeds over 100 meg per second. With this architecture. So again, same thing with internet. If your internet connection itself is unreliable, or many times ISPs promise you 10 Mbps, but they actually don't deliver you 10 Mbps 24 hours a day, and then the Wi-Fi suffers because your internet backbone is not reliable and is not giving you the adequate speed. So that's also something that you need to take into account. And lastly, the PoE, you need to understand limitations of PoE and how far the signal can go, and how to how to send the right power, and how to lay the correct cables in order to achieve as maximum out of your PoE injectors or PoE switches. So what happens because of this bad setup? You get loss of speed or throughput. You create a lot of interference. You get unreliable connectivity. Clients hop from one AP to another, and resulting in frequent disconnections with a lot of packet loss and latency, and essentially what you end up doing is wastage of your money, resources, and your time. So it's important to, as a system integrator, to understand these issues and design the right network. So let me discuss some of the best practices. I'm going to tell you about 10-15 different best practices that you need to use when you deploy Wi-Fi. So generally speaking, whenever possible, more APs and less power is kind of one thing that you need to look at. As in, don't try to broadcast too much power through an AP and hoping to cover the whole area with as less APs as possible. Design it, think over it properly. We are not saying that you should just put AP every 10 feet, but you need to at least understand what is the AP, what kind of channels you are going to assign, and whether those channels are going to interact with each other, interfere with each other, and what are the optimal number of APs that we need to deploy. As Soel mentioned, the 20 megahertz channels are necessary. You can't have You can't use random channels. Often we get customers who just take it out of the box and they select a random channel and they start broadcasting. Now, another important thing that we see, even if when you deploy the network, there are no other access points nearby, and let's say you put your access point on channel number 2. When you start your network starts broadcasting and starts running, it is very much possible that after like a month or so, there might be another access point which will be installed in channel number 1 later on. And if that happens, your channel 2 is definitely going to have interference. So it's important that if you at least configure the access point in the right channels and monitor your networks and manage your networks frequently. It's no brainer. You should try to use gigabit across all your devices. So don't just buy gigabit access points. Make sure your switches are gigabit. If you're using any other routers or any other devices in between, just make sure your firewall, for example, make sure they are also gigabit. As in, if you even have one device in your network which is not a gigabit one, it is going to actually you're not going to. It's basically going to have the lowest. It's going to take the lowest common denominator and use that. So if it's 100 Mbps, it's going to use 100 Mbps, irrespective of whether other devices are supporting gigabit or not. You need to have better APs. Again, this is a thing for what we see. But okay, Wi-Fi is something people ignore in terms of like APs. They try to put as cheaper APs as possible to save costs in the short run, but they end up actually in the long run not have a reliable network. What I mean by that is the home routers that you get, the ones with the antennas popping out, or we call them table mount routers. They are really not designed for your hotels or your enterprises, and hanging them on the wall and without even considering how the antenna needs to be placed is completely going to ruin your network. I walked into a hotel where someone has put in a table mount router and the antenna was pointing exactly in the wrong manner, and the whole signal from the antenna was getting was going either in the roof or in the ground, and all the rooms around were not getting Wi-Fi signal. So use a good quality APs which can radiate well as provide you a good coverage area and also manageability. The AP placement is another important thing. You need to place APs high enough so that it will cover the maximum area, but it should not be too high so that you create a hole below it. So the height of the access point, where to place them, and how to place them in open areas as much as possible is also important. Like you can't place APs into very congested area where there is a lot of metal and other components, and usually like right next to a metal cupboard or something like that. It's not going to help you. Channel assignments, I think Soil already mentioned about that. Make sure that you do correct channel assignments. The other important thing about other best practices is try to reduce the broadcast domain of your broadcast subnet of your network. Often we see networks which are designed with a large broadcast subnet. What I mean by that is, if you are having a large campus, like a college or a university or a large enterprise campus, make sure that you use a layer 3 managed switch and set up VLANs for different departments or different areas, so that you don't create a big broadcast network for that is going to reduce the performance. Make sure you plan your bandwidth requirements. You should do some rough calculations in order to get the adequate bandwidth. Obviously, budget is also important, but if you expect users to consume, let's say at 1 meg per second, and you are going to expect 100 users, you need to have some calculations to estimate the bandwidth requirements. There's also something called contention ratio, so you have to calculate the contention ratio for your network in order to come up with the right bandwidth requirements. Band steering is another important feature. As much as possible, try to take the users into 5 GHz band, because that is less noisy and you get much better throughput in that band. So it's important that if you have devices which support 5 GHz, enable band steering. Do a load balancing. Sohail talked about that problem earlier, where you have unbalanced network, few access points have too many devices, and most of the other access points are not having much traffic. So it's important that you load balance across the access points so that one access point doesn't get overloaded, and you segregate the traffic across all your access points. If you want to enable roaming, having a common SSID is a good thing. Don't have a separate SSID for every access point, because that is going to have, every user is going to get connected and disconnected, and whenever they hop from one network to another, or one AP to another. Separate networks, and what I mean by that is, if you are having a large area, let's say an enterprise, try to have a separate guest Wi-Fi network, and physically separate the network as much as possible in order to prevent hacks and compromise your security. This is especially true for enterprises. Try to physically separate them, or if not physically, at least virtually try to separate them. Don't try to mix up networks together and invite people to hack into the networks. And we believe in what we call as right sizing your network, and it's not necessary that everything expensive is good. You don't need to buy the most expensive access points to deliver the right performance. So you need to right size your access, your installation. What I mean by right sizing is you need to understand what your requirements are and try to find out products which match those particular features. And many times I give an example of you buying a smartphone, and you buy the most expensive smartphone available in the market, and you pay 60,000-70,000 rupees for buying that, but you end up using the smartphone only for 2 or 3 applications, and you really are not utilizing a lot of features in that smartphone. It's something similar with the access points as well, as in many people prefer to buy very expensive brands just because they, for the brand purpose, from the branding perspective. But they really don't use a lot of features, and many of those features are really built for complex scenarios or complex deployments, as in like in enterprises or large enterprises where a lot of those things become relevant. Same thing about this 3x3, 4x4. Sohail actually clearly mentioned that where it makes sense for you to deploy a 3x3 or a 4x4 access point. And if you really are not going to get advantage of that 3x3 or 4x4 access point, why do you want to spend money on buying that expensive piece of equipment? Make sure you always manage and monitor your network, and try to collect as many diagnostic logs as possible, because when you are remote, especially when your networks are remote, you need to have sufficient data with you to troubleshoot the network. So I'll quickly cover about Wi-Fi, public Wi-Fi, and this is some area where we have a lot of expertise. We have been working in this for the last 13 years. So there are basically 3 types of Wi-Fi. One is a public Wi-Fi, there's enterprise Wi-Fi, and there's home Wi-Fi. And the public Wi-Fi, the requirements are much different than other networks. As in, it's generally available for public, and there are limitations of what you can do on public Wi-Fi. And for example, you can't have a public Wi-Fi network with a shared password or a WPA password, because there is no way at an airport or a train station you can distribute out a password of that Wi-Fi network. So you need to have different security standards or different authentication mechanisms for public Wi-Fi. Security is of prime importance, as in if you don't have good security on your public Wi-Fi, then you'll be liable for a lot of things in the future. So implementing a good security and having good traceability into the network is extremely important. Lastly, next point is there are 2 types of public Wi-Fi, indoor as well as outdoor, and each one has their own challenges. Indoor are classic like airports and hotels and malls and so on. Outdoors are a lot of these smart city initiatives that we are seeing, or in public parks and many other places where people are installing Wi-Fi. So for indoor, your access point requirements are different, your design requirements are different, and in outdoor you need to have better quality outdoor enclosures and so on. So make sure you take that into account before you purchase any product. So just to the statistics, as in, although there's a lot of talk in India about public Wi-Fi, but we are still lagging way behind in terms of public Wi-Fi networks across the world. In fact, in India, a couple of years back, there were only 30,000 public Wi-Fi hotspots, although this number would have been several lakhs now, but still it is way behind. For example, China or US and Europe, they are way ahead. They have literally tens of millions of public Wi-Fi hotspots around the country. So in short, what I'm saying is there is a lot of opportunity for companies such as yours to actually leverage the public Wi-Fi market today. And I think you already know the venues that are covered using public Wi-Fi. Any place where public needs connectivity can be a potential public Wi-Fi hotspot. Now I'm going to talk a little bit about regulations, and this is also a very important topic because public Wi-Fi being unsecure means security being very important. Yeah, they need to enforce certain regulations. So as you know, in India, you always have to do the KYC of the customer. What I mean by KYC is the SMS OTP that many of you have already implemented on your Wi-Fi networks. So you always, it's a mandatory by law, and if any of the hotels or any of the places which is offering Wi-Fi to public is not doing the KYC of the customer, they are actually breaking the law and will be liable in case an event happens on their network. So it's important, as in that's also part of the TRI norms, whereby users' browsing history needs to be logged for about 13 months and stored for 13 months and made available to the law enforcement or like police and CBI and so on if they need to get hold of that information. These days there are a lot of new laws which are coming in. The GDPR law, which has recently been introduced in Europe, which talks about the privacy of the users, the FOLIA law in the United States that talk about that actually gives the power to FBI to tap anyone's Wi-Fi network and anyone's data connection is actually enacted. In TRI also has a lot of compliances or has regulations surrounding this. So for example, tomorrow there's some event that happens and as an operator, you are liable to provide information to the law enforcement or to the police or the CBI and so other government agencies if they ask you. And if you don't have that, you are actually breaking the law. URL blocking or traffic shaping control is also important. And lastly, in several countries, not much in India, but now increasingly it will also happen in India, the IPR laws are also important. So we often get requests from our US customers to provide information about people who are running peer-to-peer softwares or sharing files illegally. And it is important as an operator to comply with these regulations because as and when if you are asked to provide that, it is important that you have this information with you. So next I'm going to talk about a little bit about the network diagram or a classic Wi-Fi hotspot and how it is deployed. And many of you would already know this, but it's on the top on the right hand side you see different access points that are usually connected through a PA switch, and all those PA switches either 8-port, 12-port or 24-port, they all get connected to a master switch. This is again as a standard diagram. Obviously it will change based for every network. If some components may be missing for many of you. In some of you in your installations only one switch is available, but in a decently sized Wi-Fi network, this is the classic architecture. The master switch is usually connected to a wireless controller and a AAA server, and then you have a hotspot gateway before the internet, and the hotspot gateway is kind of a gatekeeper of the network, and that is responsible for ensuring that only valid users get onto the internet. Lastly, there might be a firewall. It may or may not be necessary for a public Wi-Fi, but definitely it is an important component when you are doing an enterprise Wi-Fi deployment. Just a Wi-Fi hotspot gateway will not suffice. You will also require a firewall along with it. Now, what is our value proposition? Many of you know Wi-Fi Soft, some of you would be new to Wi-Fi Soft, but I wanted to just highlight in context of our current discussion where we stand as a company and what we do and what value propositions we give to our partners and to our customers. So we are a 12-year-old company, a lot of expertise in deploying Wi-Fi over the years. Personally, I've been in this business for the last 15 years. And I have solid experience of building reliable Wi-Fi, not just in India but worldwide. So we offer a complete integrated solution. So what I mean by that is we offer a complete end-to-end Wi-Fi range of Wi-Fi devices. It could be your Wi-Fi access points, PoE switches, controllers, the software systems, and everything that is required to set up a Wi-Fi network. What we believe is right-sizing the solution. When I say that right-sizing means we are offering a good quality product at a reasonable price. And we are not asking customers to buy features which they will most likely not use in many cases. As in, even our Unibox has been designed with practicality in mind. And a lot of our customers like this product because we have offered a great value, a lot of features at a reasonable price. We believe in managed network philosophy, as in none of our devices are unmanaged, because unless you have a network which is managed or monitored, then only you are able to build a robust and reliable network, Wi-Fi network. So we have a lot of tools and products that gives you better visibility and control over the network. And it's important to make it simple and intuitive and simple for our end users. Many of our customers use other vendors, and they have a lot more technicalities. Some of them also have a special certification that needs to happen for your RF engineers or your network engineers to deploy those networks. But in our case, it's very simple. Everything is more or less, when you go through, it's all GUI-driven, and our products become really simple to deploy and to operate. We have a big partner network across the country. We have partners who have been working with us for years together, and we believe that that tells us a lot about our commitment to our partners and our commitment to this industry. We have, again, a global experience, R&D experience, and we are not a company which is just buying things from China or Taiwan and just relabeling and selling it here. We believe that we are going to add value to our products, and we have dedicated teams, R&D teams, to build that kind of products, and that's what we've been doing there for the last 12 years. And all of this is coupled with our fabulous support. So I'm going to just quickly highlight our couple of products. I'm not going to go deeper into these products. In fact, we are going to have a follow-up webinar about our Unibox controller next month. Isha will announce that date. And in that, we are going to cover our Unibox 3.0 release. We have recently launched, are in the process of launching our much improved and much upgraded version of Unibox 3.0. And our next webinar, we plan to discuss that product in more detail. But I'm going to just give a precursor of what Unibox is. Unibox is an all-in-one controller. It's available in different models. It's designed both for enterprise as well as public Wi-Fi networks. And more importantly, it has everything. If you look at my previous slide, where we are talking about all these components. So we have the PMS server. So the PMS server, the wireless controller, the AAA server, and the hotspot gateway. It's basically combining all these 4 products into one box. So it's what we believe is we are really creating a value here, because a classic Wi-Fi network will require all these 4 components. Whereas in our case, we are adding all of those in one box. So making sure that a lot of our customers like this because they get all these features in this one box. So I'll quickly go to the next slide. what happened here? Just a minute. Okay. So we are vendor independent. You can use our Unibox with any access point. Although we prefer that our customers buy our access points, because now we offer a very good access point at a very nice price as well. We offer complete user management, bandwidth control. It is completely TRAI compliant, TRAI DOT norms. So we are totally compliant with all the TRAI regulations, and we offer hotspot billing features, PMS, LDAP, G Suite, social media, all different types of integrations are enabled. SMS integrations are enabled in that. We are in Unibox 3.0. We'll be also introducing a wireless controller feature, whereby we can manage access points through our single controller itself. We have multi-band. You can use multiple internet connections and club them together into our box. Web filtering, we have firewall features, policy management, and a lot of reporting and analytics. So, as I mentioned, I'm not going to talk much about Unibox. We're going to have more detailed presentation or webinar in our next webinar. Will cover the 3.0 features of our box. I'll also talk about our access points. We have a lot of different types of access points: indoor, outdoor, N series, AC series, and all of them, we build them as enterprise class access points. They are all PA enabled. They are all managed, and as I said earlier, we right-size them. So we are not making them too expensive by just thrusting them with a lot of features, and where most of those we will not be using them. So we right-size those. They are all cloud controller managed. They are hotspot ready. So they all have captive portal functionality in it. And they all, more importantly, they are all single console management. So you can basically manage all these access points, remote access points through the single console. And a lot of different advanced features, some of which Shoaib had been describing earlier. Recently, we also launched our PoE switches that work seamlessly with our access points on many other devices. The IP cameras, access points, IP phones, and many other PoE-enabled devices. So they are 82.3 AF and 80 compliant. All are high power and different models, gigabit PoE, and you have fiber and fiber uplinks and gigabit uplinks for those things. Ports available, so you can basically start these switches and create as much as you can. As in, if you have if you need it for 100 devices or 200 devices, we have a PoE switch or a set of switches that can be deployed for powering all those devices. So very good for IP cameras, where our Wi-Fi installations, or many other places where you want to get PoE power. So that's bring to the end of my presentation. I think thank you very much for patiently hearing us. And I'm going to now discuss some of these questions that have come in. Would you be able to download the PDF presentation? Yes. So I'll hand it over to Isha. Isha is going to wrap up the discussion. If you have any other questions, feel free to get in touch with Isha, and she will be happy to answer them or send you answers. So I'm going to just hand it over to Isha, and we'll wrap up this webinar. Once again, thank you very much.
Hello. Yes. So I just wanted to let you guys know that we will be circulating the presentation after the webinar only. I just want you guys to just consider, liking us and reviewing us on Facebook and Google reviews. Along with it, along with the presentation, I will even be sharing a feedback form. And I would like you all to reply and respond with, your views on how the, presentation was and what the webinar was all about, and, what topics you would like us to discuss next. So that will give us an insight into what your requirements are and how we can make ourselves better. And even along with that, you will be, you have the chance to win exciting prizes, and you can win event invites that we will be having in the future. So you will be able to win those invites as well. So now I'll just open the floor again for the question and answer from Mr. Rishikesh Ghare and Mr. Sohail Ahmed.
So we have a question from one of our team members, one of our partners. The question is, do you have Wave 2 APs? We are actually introducing within few weeks. We are going to introduce a Wave 2 AP as well. We already are doing some testing and pilots and building the right firmware on it. So yes, our answer is we will be having a Wave 2 AP shortly within few weeks available to our partners and to our customers. There's another question about downloading of the PDF on this presentation. Yes, Isha will send all the participants a link after this presentation whereby you can download this presentation, as well as we're going to keep a recording of this on our website of this webinar for all our partners to download if they want to hear it offline. Another question we are having is when are we expecting 3.0? We are expecting to release 3.0 in first or second week of June. So it is in its final run where we are doing a lot of intensive testing with the box, and we hope to have it launched by first or second week of June. So it will be generally available to all our partners and our customers from starting of second week of June. So please contact your sales representative so that they will provide you the correct timelines as well as the pricing for the new 3.0 version. If there are any more questions, please feel free to type them. There are a lot of people who were on this call, on this presentation, and we got a really good response. So thank you everyone again for being a part of this webinar, and we hope to keep on making Wi-Fi simpler to all of you in the coming months. Every month we are going to have a webinar discussing various topics about Wi-Fi and the new technologies that are available in the market. So with that in mind, if there aren't any other questions, we'll wrap up the webinar. Thank you again everyone, and we hope to hear from you in the coming weeks. Thank you. Bye-bye.